These are lecture notes for 7.1 in the textbook. All right, so I was done with 6.4, and Wednesday the 10th should have been 7.1. Tomorrow 7.2, quiz 6. I'll ask you a question very similar to the in-class assignment on Monday. So look back at what we did over there. I'll give you sine, cosine, tangent, secant, cosecant, cotangent of a particular angle, and you figure out what quadrant you're in, and I'll ask you to find the other 5 trig functions. So work it out in a similar fashion to that problem that we did over there. I'm changing the assignment just a little bit in 7.1. It was originally 1 to 35 odd, skip 35. So the last one we're doing is 33. Okay, and so here's what we have. So 7.1, for those of you who don't have the book, 1 to 30, it's not 1 to 33, 477. Here are the questions, and some more, and some more. Some more there, and there, and the next page. So we have to go up to 33 now, not 35 anymore. And hopefully you can catch everything there, okay? All right, and stuff that I introduced last time. So on page 470, 180 degrees is pi radians. Formula for arc length, the length of an arc, S equals R theta. There's the picture, figure 9. Theta has to be in radians. Okay, that was on page 472. 473, the area of a sector of a circle, like a piece of pie, 1/2 r squared theta. Theta has to be in radians. Okay, these come from a fraction of a circle. The formula for the area of a circle is pi r squared, and you just take the fraction of the whole pi out of the full 2 pi. And likewise, to get the formula here, the circumference formula is 2 pi r. You just take the fractional part of that arc length as a fraction of the whole thing, and it comes out to be S equals R theta. Okay. All right, so 7.1, page 477, supposed to be from Wednesday the 10th. S equals R theta. So question 1, 5 is equal to 2 theta. Here's the picture. The arc length is 5. The radius is 2. Okay, so I just plug it in. 5 equals 2 theta. So theta is 5 over 2 radians. All right, you have some problems changing degrees to radians or vice versa. Okay, now we said that pi radians is 180 degrees. So how do you know if you multiply by pi over 180 or 180 over pi? You just need to get the units to line up. Okay, so 5a, you have 45 degrees. So you have degrees on top. That means you want degrees in the bottom so that the degrees would cancel out and radians would be on top. R stands for radians. Okay, so 45 degrees, pi over 180 is what I want, because then that degree on top would cancel the degree in the bottom. Okay, 45 goes into 180 exactly 4 times, so pi over 4 radians. And after a while, we get used to not even putting the R. If I just put pi over 4, it's understood to be radians. Okay, 90 degrees, same thing. Cancel out the degrees by putting pi over 180. Okay, 90, 180, so pi over 2 radians. And C, 135 degrees, same thing. Multiply by pi over 180. Pi radians is 180 degrees. That will cancel that degree. Both of these go into 45 go into both of these. 45 times 3, 45 times 4, so 3 pi over 4. Okay, now if you're going the other way, they give you radians, write it as degrees. I want 180 over pi because I have pi over 12 radians. I need to cancel the radians, so I put the radians in the bottom, pi radians, and degrees on top. That way radians would cancel out. And pi's cancel out. 180 divided by 12 is 15 degrees. Okay, pi over 6 radians, same thing, multiplied by 180 over pi. Pi's cancel out, radians cancel out. 180 over 6 is 30 degrees. And C, pi over 4 radians, again, multiplied by 180 over pi, so the radians cancel out. Pi cancels out. 180 divided by 4 is 45 degrees. Okay, 13a, it says 2 radians. What is 2 radians in terms of degrees? So again, I need to cancel out the radians, so I multiply by 180 over pi. Radians cancel out. That's an R there. So I have 360 over pi. Punch it in your calculator. 114.59 degrees, rounded to the nearest hundredth, it said, 2 digits. Okay, B says pi squared radians. This time I didn't bother putting the R. It's understood to be R. So 180 over pi radians, so the radians cancel out. One of these pi's cancel one of these pi's, so I have 180 pi. Punch it in a calculator, 565.49 degrees. Okay. Question 15 says, suppose the radian measure of an angle is 3 halves. Without using a calculator or tables, determine if this angle is larger or smaller than a right angle. Hint, what is the radian measure of a right angle? Well, we saw that 90 degrees earlier was pi over 2. So pi is like 3.14. So 3 over 2 is a little bit smaller. So 3 over 2 should be a little bit less than 90 degrees since pi is bigger than 3. Okay, number 19. I use the formula S equals R theta. So 19, find S. The measure is 4/3 pi, or 4 pi over 3. The radius is 3 feet. So the formula is S equals R theta. So 4 pi over 3 times 3 feet comes out to be 4 pi feet. 23a asks for the area. Okay, so R is 6, theta is 2 pi over 3. So I use the formula area is 1/2 R squared theta. So 1/2 6 squared, 2 pi over 3. Crunch it out, you get 12 pi centimeters squared, square units for area. And in a calculator, that's about 37.70 centimeters squared. Okay, part B, theta is 80 degrees. Now you have to change that to radians first, because the formula 1/2 R squared theta must be in radians. So if it's in degrees, you change it to radians. So 80 degrees multiplied by pi over 180, so the degrees will cancel out. And reduce, both of these are divisible by 20, so take out a 20, 4 pi over 9 radians. So now the area is 1/2 R squared theta, so 1/2 5 squared times 4 pi over 9 comes out to be 100 pi over 18, or 50 pi over 9 square meters, 17.45 square meters. Okay, 27. To give me this picture, you find the perimeter of the sector and the area of the sector. So this piece of pie, how far is it all the way around? Well, I know that's 5. This is 5. It's a radius. So I just have to take 5 plus 5, or 10, add it to that arc length. And then I just use the formula for the area of a sector. 30 degrees, I have to change to radians. All right, so S is R theta. 30 degrees, that's a 30 there. Multiplied by pi over 180, and that gives me pi over 6. And notice after a while, I don't write the R, it's understood to be radians. So the arc length is R times theta, 5 times pi over 6, 5 pi over 6. So now for the perimeter, it's 5 plus another 5 plus this arc length, which I just found to be, it should be 5 pi over 6. So 5 pi over 6. So this is now wrong, sorry. So 5 plus 5 plus 5 pi over 6, or 10 plus 5 pi over 6. Okay, so I guess I should get that for you quickly. What I had originally was wrong. So 5 pi divided by 6 plus 10, 12.62 inches. Okay, then for the area, I use the formula 1/2 R squared theta. So 1/2 radius is 5. 5 squared theta is pi over 6. So it comes out to be 25 pi over 12, or 6.54 square inches. Now, 29 and others like it, you have the rate of a rotation of a wheel. You have a spinning wheel. Okay, they're asking you for the angular speed in radians per second, the linear speed in centimeters per second, and the linear speed in centimeters per second of a point halfway between the center of the wheel and its circumference. Now, you could come up with a formula for this, but you don't have to. This is sometimes called units analysis. You just try to get the units to line up the way that you need it to be. And I'll show you what I mean. So 29, 6 revolutions per second, radius is 12 centimeters. Okay, so here's how you can work something like that out. 6 revolutions per second, radius is 12 centimeters. Okay, now you want radians per second. You have revolutions per second. So I need to get rid of revolutions and change it to radians. Okay, so 6 revolutions per second. I know that 1 revolution is 2 pi radians. If I go all the way around a circle, that's 2 pi radians. So this is 2 pi radians per revolution. The revolutions cancel out. So I have 6 times 2 pi, 12 pi radians per second. And that's what I want for part A. Part B asks for centimeters per second. So I have to convert radians to centimeters. Okay, so I have circumference is 2 pi r, 2 pi times 12, 24 pi centimeters is 1 revolution. Excuse me. Okay. So what I do now, since I know 24 pi centimeters is 1 revolution, I lay down to 6 revolutions per second. I want centimeters per second. So I need to lose the revolutions and get centimeters. And so I put 24 pi centimeters per 1 revolution. Revolutions cancel out, 144 pi centimeters per second. Okay. Finally, it said a point halfway across. Well, the radius was 12 centimeters, so halfway would be 6 centimeters. So circumference of that innermost circle is 2 pi times its radius, 12 pi centimeters for 1 revolution. Okay, so I do the same thing. 6 revolutions per second. I need to cancel the revolutions. So revolution on the bottom, 12 pi centimeters is 1 revolution in this case. So revolutions cancel out. So 72 pi centimeters per second is the speed halfway across in this particular case. Okay, so that's it. Let me raise it up again for focusing purposes, and then you can watch the video later as necessary. And there's that. Right, so that in a nutshell was section 7.1 for the lecture for Wednesday, March the 10th.